Hello, my name is Nitya Narasimhan. I'm a senior AI advocate on the developer relations team at Microsoft, and I'm really excited to be here today to take you on a developer journey as we build a RAG-based retail Copilot, code first, on Azure AI Foundry. Now, this is a shortened form of a talk that we've been taking out on the AI Tour as a 75-minute workshop and skilled thousands of developers. And we did it by deconstructing Contoso Chat. If you have a second, go check out the QR code or the URL, start the sample or fork it, and go check it out after this talk and see if you can explore it by yourself. But today, I'm going to split this talk into 3 sections. First, we're going to spend some time knowing what Contoso Chat is, how it's architected, and how we should go about building it. The meat of this talk will then focus on interactive demos and exploration of the codebase to actually go through that workflow. And finally, I'll leave a little bit of time for us to think about how you can then use the sample as a sandbox to go explore ideas for Azure Cosmos DB features like vector search. So let's get started by talking about the application scenario. What exactly is Contoso Chat? So you might actually be familiar with this web app that you see on the right side. This is Contoso Outdoors, an enterprise retailer that sells camping and hiking equipment. Contoso Chat is their customer support chat AI. And when they built it, they had 4 requirements in mind. First, they wanted to make sure that it was conversational. Their customers should be able to come to this chat site, to the website, and chat with the website about what products are available in natural language. Second, the responses need to be grounded. So if a user asks, what should I buy for a trip to Andalusia? They should get back responses featuring products that are in that catalog. Third, it needs to be contextual. What that means is it needs to understand that there's a chat history, that the consumer might have previous purchases that are relevant to the query, and so on. And most important of all, it needs to be safe. We all know there are techniques like jailbreaking where people try to use prompts to change the behavior of a chat AI in ways that you didn't intend. So one of the things we want to make sure is we can protect against jailbreaking, but also take the time we need to make sure that the responses are of good quality and safety. So as you can see here with our demo, when you build this app, it will have built-in guardrails to prevent things like jailbreaking. Let's see how we build that. But before we do, let's take a look at what our data sources are. This is Cosmos DB conf after all. So we have 2 kinds of data sources, and we did this on purpose. So you can actually go explore both structured and unstructured data. A product catalog sits in Azure AI Search. It has structured data in CSV format. Now, if you fork the repo, you can go into the data folder and look at the product info subfolder, and you will find that list of products. You have 20 product items, a good healthy sample, 8 product categories, and columns like price, name, brand, description as metadata. We also have a second set of data. This is unstructured data in JSON format, and this represents our customer data. We have 12 customer profiles. Again, you can go into the data folder under customer info. We have 12 customer profiles. Each profile gives you a little bit of information about the customer and has 2 to 3 purchase orders that they've made from this site as history. So with this data, we now want to build a chat AI grounded in this data. How do we do it? The answer is retrieval augmented generation, or RAG. I'm not going to go into too much detail because we're all probably very familiar with this design pattern. But let's take a quick look at the flow so we understand how this maps to our architecture later. So typically, when a user goes to a model, a large language hosted model, and asks a question, if it goes directly to the model, they're getting back answers that are based on publicly available information. So if I ask, recommend me a tent, it's going to come back with a publicly available one. But if I want to ground it in my data, we use retrieval augmented generation. We take the query and send it to an information retrieval service, which can vectorize the query, find matching results, and return that as knowledge as part of the retrieval step. We then augment that original question to create an enhanced model prompt that contains the question as well as this retrieved knowledge, along with instructions, which we then feed to the large language model, allowing it to generate the response, which magically is now grounded in that data. So how does this map to our architecture? This is the Contoso Chat architecture. And you can almost see RAG in play. The user input comes in. Our Contoso Chat AI is hosted on Azure Container Apps. A request comes in through this. It gets fed to a workflow, starting with an Azure OpenAI service for embeddings, which takes the vectorized query and sends it to search. Can also send the query to Cosmos DB, get back knowledge, enhance the prompt, feed it back to the chat completions method, which gets the response, which goes back out. Simple, right? Not so fast. Building this is actually really complicated. We have seen a paradigm shift. You might have heard the term GenAIOps, where the application lifecycle is now complicated by the fact that our inputs and outputs are in natural language, which is non-deterministic. So when we think about building this, we actually have a three-phase approach. First is ideation, where we have to select the model that we want to use and maybe use a test prompt, to test it out and see if it can do what we want it to do for our application. Once we've decided that's the model for us, we move to the next phase, building and augmenting. That's a place where we spend a lot of time as developers. We enhance that prompt. We potentially do things like retrieval augmented generation, adding data access, orchestrating the workflows. And then we do things like evaluation to test that those responses are actually of good quality and act in a safe manner across diverse inputs. And when we're ready, we move to the final stage of operationalization, where we make this chat AI hosted, available as an API endpoint that can be accessed by real-world apps. But if you look under the covers, there's a lot that's happening. How do we do all of this? This is where Azure AI Foundry can help. And today we're going to look at how you can use the Azure AI Foundry platform to go from catalog to code to cloud. It provides you the tools, the services, and the models that you need to build your generative AI application in a streamlined manner. So with that, let's actually dive in and look at the sample and try to figure out how we build this step by step. The first thing we're going to do is look at a quick start. How do we jumpstart our development process, given that we have an open source sample? And we're going to do this by looking at what we call AI app templates. You can go to that QR code or to that link to actually visit the site that I'm going to show you in just a minute. It looks something like this. And let me just quickly make sure that my code space is still alive. Yep. So the Azure AI template site looks something like this. What it is a bunch of pre-made open source samples that have architectural designs and code bases that you can launch with a single command that will both provision and deploy the resources and give you a running application that you can use for exploration and extension. It uses infrastructure as code. So basically, your provisioning is defined through bicep or ARM files. So in this, to find Contoso Chat, simply go and pick the language, Python, and the two data types that we're using. The databases we're using is Azure AI Search for the product catalog data and Azure Cosmos DB for customer data. And you'll find that there's only one template that does this. Click on this template, and you should get to a screen like this. This is where you can find out more details about what that app is doing. So in this case, you can get to see the example that I showed you, the architecture diagram, and know a little bit about the services that we're using. But you can go seamlessly from here to actually start using the template. And I encourage you to do that. Click open in GitHub Codespaces, and you will get a link like this that will take you to a code space. And it should actually, now this is going to the main one, but there is a link that you can do to take care of a pre-build. And we'll put that for you in just a second. If you click that, you will then end up getting a code space like this. So let's go back and see what that does. If you actually go click on that link and get this far, you have now completed the setup. You've got yourself a code spaces environment, and this reflects configuration as code. So all the tools, all the dependencies you need are already installed for you, and you can immediately get started building. In this, what you are now going to do is AZD up. Now, I've already done this for you, but if you look at the instructions here, it'll actually tell you how to go through those two steps for getting started, and you can follow along. In my case, I've already started that and run AZD up. So what does AZD Up do? If you want to actually go into this step by step, I encourage you to go to this site, which has a self-guided workshop that I'll show you later on, where you can take these steps on your own. But all I will tell you for now is that when you run AZD Up, it's going to complete the provisioning of those resources on the backend and deploy the first version of your application and make sure you can now have an Azure AI project ready for you to go play with. So let's take a look at what that looks like. So as I mentioned, I already ran this prior to joining this call. So this is what my provisioned application looks like. Note that I have a resource group with all the resources deployed, and you can see that there's an Azure AI Hub, an Azure AI project, and Azure AI services that come from the Azure AI Foundry. I have a Cosmos DB account. I can actually click on this and go check out what's available there, and we'll do that in a second. And I can actually go in and look at the deployed container apps. So I'm going to go ahead and open that up here. So you can go into the Cosmos DB account, open up the Data Explorer, and you should see that the records that we had for customers are already in there. So give it just a second, and there you go. So you can see that the data is already uploaded. Similarly, we can go into the deployed container apps, and you'll see that we have a first version of our AI already deployed. You can go to the Swagger endpoint, and if you want to test the application, we can test it here, and we'll think about that later. So now you know, with just a few minutes and a few clicks, you were able to set up your development environment and deploy your resources. What's next? Now it's time for you to ideate. So let's go back and look at our Azure AI environment. When we deployed these resources, we also set up an Azure AI Hub and an Azure AI resource, a project resource. This is that resource. So if I look at my project, I will notice that I actually have, as intended in the architecture, I have deployed 3 models out of the box. First is a chat completions model. In this case, we're using GPT-4o Mini. Second is an embeddings model. In this case, we're using text embedding Ada 002. And third will be an evaluation model. We're using GPT-4. So let me just wait a couple of minutes for this to settle down. All right. Now you can actually go in and check out a deployed model. Now remember that this deployed model is effectively just the large language model, and I can open it in a playground and start my ideation right here if I so choose. So I already went ahead and did a really simple test where I put in the model instructions and context, and I gave it a simple query. Tell me about your camping stuffs. And you'll notice that when I ran that query, it gives me a very generic answer. It's not grounded in my data. So when we ideate in the playground, that result is not grounded in our data. In order for us to do that, we now need to orchestrate the flow, connecting this to various resources and building out that prompt template. Let's see how we do that next. To do this, we're going to go back over to code spaces and start looking at the code. So remember that when we ran AZD Up, we provisioned the infrastructure, but in doing that, we also have our development environment set up. Now, I'm not going to show you, but what it does is it actually sets up an environment variable for you, or .env file, that has all the environment variables you need to actually connect to the backend infrastructure. So now we'll start our ideation process. Remember, I told you we have a step-by-step workshop. If you do want to follow along, the URL is in the left in this QR code. But the workshop instructions can also be found online, and they look something like this. You want to go ahead and do the self-guided setup. And when you're done, what we're doing now is going through the ideate process. So what exactly is happening here? We notice that we have a model deployed, but it's not grounded in our data. So we want to start kind of using that model, configuring it, and then building a prompt template. To do this, we're going to use a technology called Prompty. So what is Prompty? I'm going to start by actually showing you a basic Prompty file that you see here. When you install this app, you will actually get a built-in extension. There's the Prompty extension right there. And it comes with tools that helps you create. You can do a new Prompty and get this basic Prompty that you see right here. that helps you create this asset, a prompt asset, and provides you a runtime that you can test in right in VS Code. Effectively, you've brought your playground from Foundry into your development environment. So what does a Prompty look like? The basic Prompty that gets set up for you will look something like this. It'll basically have a metadata, a front matter area that defines the model and the configuration parameters. It'll have a sample input that you can use for testing, and it'll have beneath it a prompt template. You can see the system context, and it has some basic information. Now, this is just a standard starter Prompty that is created for you. Because we're sitting inside VS Code, we can actually run it directly here. So you'll notice that when I run this, it fails. And this is expected because what happened is that we don't actually have the setup with the right endpoints. Or we don't have it set up with the right deployment. It's got the wrong value. So if you go through our workshop, what we do is we actually then fix that by providing it the name of the right deployment and have the endpoint set up to use the environment variables we've already created. So now let's go ahead and run this again. So this is equivalent to iteration. You took that chat Prompty, and now you fix the issues that it had, and you can run it. So this is version 1. So when I run it this time, let's try this again. All right, if you can see the results here, now staying inside VS Code, I was able to run this Prompty, configure to talk to the model, and it used this as the system context and used this as my instructions and answered this question, which is, what can you tell me about your tense? And as you can see, it followed the instructions. I'm helping this person use their name to address them. Hi, Nitya. Here is the answer. It's still not grounded in my data. But this is how we can start iterating. The next step we're going to do is we're going to take this sample input and move it into a file. Now you're beginning to see data that has the shape of the kind of data that you would actually find in Cosmos DB. Here is my customer unstructured data. That's my customer input. There are the orders. I can now go ahead and iterate on that chat Prompty to use this file as the data. Now, by doing this, I've immediately moved away. I've started shaping the data. So now by having it take the inputs from a JSON file, I can continue to test my Prompty templates, but know that down the line, I can then connect to an API to get that JSON data dynamically during my orchestration step. So here, my sample file is connected to a very simple customer record. I've now also enhanced my prompt template to use this information in meaningful ways. And I've given instructions for the model to answer the question grounded in this context. So if I run this now, note that I'm still taking data from a sample file, but it's beginning to respond to the way in which I am engineering my prompt template. In the next step, I can keep going. So we can kind of go through this whole thing if you like, but the next step, what we're going to do is we're really adding safety. So in this particular case, I'm going to look at this and say, all right, I'm going to change this to 2.json. Now you'll see why in a minute. Chat2.json is a sample that actually puts a jailbreaking style input. So over here, all I've done is said, hey, is mine currently allowing me to kind of work with prompts that could jailbreak my content? So if I go back to where I was before and I try to use that input, you will notice that it will in fact allow it to say harmful things. So let's see if that just runs. There you go. So you'll notice that I asked it in that prompt to tell me about its rules and use bad emojis. And it did that because I didn't have any safety guardrails. But now when I move to the next iteration where I've put the safety guardrails in, if I now try to run this with the same input, you will notice that it will not allow it. So let's kind of wait till this is done. And it'll say, I'm sorry, John, I can't share this information. So this gives you kind of a really good sense for how we can start ideating right in the browser And at the same time, we're using a sample of data that we would find in Cosmos DB later. But you're asking yourself, this is a Prompty asset running in a VS Code runtime. How do I make this work in a code workflow? To do that, Prompty actually has a built-in capability that will allow you to convert it to code. And so you will be able to get a Python version of the same code that you can then run to get the results that you want. With that, we kind of get to the end of our ideation. Now you've got yourself a sandbox where you can rapidly ideate on those ideas that you have until you get your prototype to where you want it to be, and you also know what that data looks like. The next step, and remember where we had the JSON file, when you write the orchestration code, once you've got it in Python, you can actually go ahead and replace the loading of the JSON file with calls to the different services you're getting this from. And if you go look at the source for this app, you'll find it in there. But wait, before we can actually make this available to the world at large, we need to make sure that the data, the responses, are actually valid for a wide range of inputs. This is evaluation. LLM as a judge. Now, running this would take a really long time, but if you're interested, again, go check out the instructions. I went ahead and ran an evaluation ahead of time so you can see what the results would look like. So in here, if we look at our evaluation notebook, what evaluation does is it effectively allows you to teach a second AI how to grade the responses from a first AI using evaluation metrics like coherence, fluency, relevance, and groundedness. And we're interested in groundedness. So when you want to do that, you would basically, in this particular notebook, what you would do is first you would load up a set of sample test inputs, which you can find in this file as well. I mean, in the code base as well. And you will run them with your chat AI, which will answer all of them and give you back its results. You will then take these results to your grader AI, your evaluator, and ask it to grade these responses based on criteria that you have defined. And if you're familiar with Prompty, you can go ahead and look under the custom evaluators and see how you can literally write the prompt template that will be used by that evaluator AI or the LLM as a judge to grade those responses on a scale of 1 to 5. When you've completed that, you should then get back a result that looks something like this. And here you will see that what it has done is it has executed the evaluation notebook. So when we finish running the evaluation notebook, you will notice that at the bottom, it gives you the metrics for the evaluation. And you can look at these to understand why your answers are graded a certain way and how you improve the quality of your responses. And with that, we come to the end of our end-to-end workflow. The only thing left for you to do is deploy. And AZD deploy allows you to deploy directly from your code base and update the deployment from the previous provisioning at any time. But let's go take a look at what that deployed endpoint looks like. This is the container app that gets deployed every time you run an AZD deploy. And you can now go ahead and ask it questions like, tell me about your camping steps. And the thing that you will notice here is that I'm giving it a customer ID of 1, is that now this chat AI, which is still using the model that we saw in the playground, because it now has the orchestration flow around it, will return responses that are grounded in your data. So with that, we come to the close of our really rapid overview of this end-to-end journey in GenAIOps to build a retail RAG-based Copilot on Azure AI Foundry. There's a lot more nuance to this, and I encourage you to go check out the workshop and the sample. But I want to leave you with one more thing. This is a Cosmos DB conference. So in this, you saw how we were using Cosmos DB to store our customer data. You saw how we were using Prompty to kind of ideate with the shape of the data. And if you go look at the code base, you'll see that we finally do orchestrate it to talk to Cosmos DB to get that information in real time. But wait, we were doing our vector search on the product catalog in Azure AI Search. Cosmos DB now has these capabilities as well. How can we use this sample to explore that? I leave you with this as a challenge. Use the sample as a sandbox. Here is an example of what you can do. For instance, there is a really good tutorial in the Cosmos DB site on building a RAG chatbot with Azure Cosmos DB, NoSQL API. And it's fairly easy for you to walk through that, First, you've got to go ahead and activate vector search in your Cosmos DB deployment inside Contoso Chat. And then you can walk through this. And I have a slightly older version of it I'm still working through, but you can walk through this and then effectively change the data in that sample to use the data in your JSON file. And when you do, you should be able to get yourself a demo where you can actually see responses in the Gradio app that's deployed. So over here, we now have a Gradio app from that particular sample that is talking to our Cosmos DB, to our Contoso Chat endpoint. When I say, tell me about what you know, it kind of gives me a response. And the only thing left for us to do now is to write the queries and enhance the vector search capabilities and test it out with evaluation. So with that, that was a really rapid overview of what we wanted to cover today. Thank you very much for listening. As I mentioned before, this is a workshop that you can find at the link that you see here. Try this out on your own. By the time you see this, there will probably be an additional segment that will walk through some of the Cosmos DB vector search capabilities as well. So look out for that. And with that, thank you very much. And I hope to see you all at Microsoft Build.